Atmospheric pressure is defined as the pressure exerted by the weight of the air in the atmosphere. Atmospheric pressure at sea level is 14.7 psi-A, or pounds per square inch absolute. This value is lower at higher altitudes and higher below sea level. An Italian scientist named Torricelli invented the mercury barometer, a device to measure the atmospheric pressure in inches of mercury. The mercury barometer works as follows. A tube of mercury is inverted in a container filled with mercury. The column of mercury inside the tube falls only to a certain height before it stops. The height of this column of mercury is always the same with an atmospheric pressure of 14.7 psi-A and is equal to 29.92 inches of mercury. This is because the atmospheric pressure on the surface of the mercury in the container balances the weight of the column of mercury in the tube and the vacuum on top of the mercury in the tube. The space in the tube above the column of mercury is an absolute vacuum. This figure illustrates the different units for pressure and vacuum measurement. The common scales for pressure measurement are PSI-A, that is, pounds per square inch absolute. This is a scale which starts from a perfect vacuum and shows a reading of 0 at this stage. PSI-G, that is, pounds per square inch gauge. This is a scale which does not measure atmospheric pressure. This scale is at 0 with atmospheric pressure. Notice that the reading on the PSI-A scale is 14.7 at this stage. Inches of mercury vacuum scale, which gives the vacuum reading in inches of mercury. This scale shows 0 at 1 atmosphere pressure. This increases with increase in vacuum and shows 29.92 inches of mercury at perfect vacuum. Inches of mercury absolute scale, which gives the pressure in inches of mercury. This scale shows 0 at perfect vacuum and increases with increase in pressure, including atmosphere. The relationship between the different pressure scales is discussed here.